All right, this is about 9.4 compositions of transformations. After this lesson, you should be able to successfully apply compositions of transformation to figures and describe the output transformation, meaning what happens after you do a double transformation. So you have some words to fill in on your worksheet. When two transformations are applied to one figure, one after the other, the total transformation is called a composition of transformations. A glide reflection is a translation followed by a reflection in a line that's parallel to the translation vector. Notice that the composition of isometries is another isometry. So basically, if you're reflecting twice, the size of the figure is not going to change. That's what an isometry is. A better term for that is the rigid motion. So a double reflection and a translation still will be the same size figure. It's all that same. Okay. A combination of a translation and a reflection, the line that you reflect over, if it's parallel to the translation vector, that's called a glide reflection. So this is an example of a glide reflection because the little happy face and the vector, this is a slide of the figure, that and the reflection line, which is horizontal with both, they're both going the same direction. Both of those happen to be horizontal. That results in a glide reflection. We're going to try one. This one's not one. We're just going to do this one. So first we're going to plot the points that are the original points. They are listed right here. So I need to slide this screen down. I'm going to do those in blue. And what we're doing to it is first we're translating along the vector -5, 0. So the second points, which I'm going to do in red, they're going to go, this would mean left 5, and then don't go anywhere vertically. Okay, so all you're doing is translating left 5. So the same process can be done to translate left 5. You can physically move your points left 5, or you can subtract 5 from their coordinates. So the way they got A prime was doing 3 minus 5, and that gave them -2, 3. To find B, they did 4 minus 5 and got -1, -2. And to find C prime, they did -1 minus 5, which would give us -6, -3. Okay, let's get those. And then after that, we're going to reflect in the y-axis. Now, this vector is going this way. Okay. The reflection in the x-axis runs the same direction as the vector. So this will represent a glide reflection. Okay, so I'm going to go down to the grid, and I'm going to plot the points, but I got to be able to see them. So I got to plot 3, 3, A, 4, -2, and label it B. -1, -3 is left 1, down 3. Some of you forgot how to plot points recently. They're X first, then Y. Okay, so here's our original triangle. Okay, we've already written down the location of A prime, B prime, C prime. That's going to be at -2, 3, which is just taking all these points left, 1, 2, 3, 4, 5. There's A prime, that is at -2, 3. C, left 1, 2, 3, 4, 5. And B, 1, 2, 3, 4, 5, which gave us -1, -2 for B prime. C prime is at -6, -3. That's left 6, down 3. Okay, I'm going to draw the figure. So now we see the translation, which is a slide. We are then being asked to reflect over the x-axis. reflecting over the x-axis changes the y values of the coordinates, only the y value. So A double prime would be at -2, -3. B double prime will be at -1, +2. And C prime was at -6, -3, and it's going to go to -6, +3. Okay, so now I'm going to plot those points. So I'm reflecting, and if you want to, you could just flop them over the x-axis. Let me show you that again. The x-axis is here. Ooh. Glad that straightens out for me. Okay, now A is 1, 2, 3 above the x-axis, so we would go 1, 2, 3 below. I'm going to have to move my letter C because it's in my way. So I'm going to -2, -3. That's A prime. If I reflect C over 1, 2, 3 below, you go 1, 2, 3 above. That should be at the point -6, 3, and it is. And B, let's see, should be at -1, 2. Okay, that's B prime. Because we're reflecting the red one. Okay, and this is a glide reflection. Well, that's what it looks like. Okay, does anybody still need this page? Wait a minute. No? All right. This is just a chart. I think you have to turn your page. That you don't have the middle column. We condensed it and just gave an example of a reflection of the letter P. We put the phones away, please. A translation is a slide. And a rotation is a turn. So just a picture of that. And then the glide reflection. Slide and flip. Although I'm not feeling it for that picture. I don't think that's really the best picture we could have for a glide reflection. Okay, let's check out. All right, the next one, we've got triangle XYZ with vertices at 6, 5. We got to start plotting. So 6, 5 is right, 6 up 5. Label that X. 7, -4 is right, 7 down 4 from the origin. 5, -5. Okay. We're going to draw the figure first. And then I'm going to do a different color, its image after the indicated glide reflection. 0, 2. That would mean going up 2. So if I take every point up 2 units, X prime will be right up there. And we're going to get some that are kind of on top of the original figure a little bit. Not much of a move. Grab a pen. Connect all these and just show that triangle slid up 2 units. Now they're telling me to do a reflection in the y-axis next. So first I'll highlight the y-axis, which is your vertical axis. We're going to go over it. And I can just count. Well, what that does is reflection in the y-axis. We'll take the red points, the points that we have here. It will change the x values of them. But let's just do it. So since x prime is 6 to the right of the y-axis, let's just slide over 6 to the left. Staying on the same line where 7 is, meaning I'm staying on this line that is the line y equals 7. So I went 6 to the left, x prime, double prime, we need to label it. And I'll do the same thing with the other 2 points. I'm 5 away for z, and I'll go 5 to the left for z prime. Y prime is actually 7 to the right side of, did I say left a minute ago? I want to make sure I'm saying that right. Z was 5 to the right. You needed to go 5 to the left, staying perpendicular to the y-axis. Y is 7 to the right, so stay on the same line. Y is horizontally. Go over 7 to the left. That should be Y prime, double prime. Sorry, I need double tick marks on all of my points. And then I'll finish off drawing the figure. Ooh, I made it really pointy. Okay, this was a glide reflection. Slide and a flip. Now, how do I know definitely that it was a glide reflection? The y-axis is going in the same direction as the vector. Okay, see how the vector was going straight up? And so is the y-axis, the reflection line. So this would be, yes, it is a glide reflection. I don't know why that question was there really when it says after the indicated glide reflection. But anyway, it is one. I'm not going to really test you on knowing when you look at a picture if it's a glide reflection or not, but I would expect you to be able to do one, okay, where I ask you to translate and then reflect. Okay, we're going to be drawing the same figure again as the last one. These are all the same points, 6, 5, 7, negative 4. So I'm just going to start off with my blue triangle again. Okay, and then I'll do my second thing again in red. Along the vector negative 3, 4, that's going to be left 3 with each point and up 4. Now going left 1, 2, 3 and up 1, 2, 3, 4 actually produces a vector that goes like this. See how I could just pick, if I connected from Z to Z prime, I would have an arrow that kind of goes like that. Okay. All right, so that's the direction of the vector. The x-axis goes this way. So is that going to be a glide reflection? These don't match. So that would be a no. We already know before we even start that it's not going to be a glide reflection. All right, so let's continue moving the points. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Okay, and now I'm supposed to reflect in the x-axis. Ooh, wow, this is going to get a little messy. Here's our x-axis. I'm going to go over that. So let's see. X prime's 9 above it, so I go straight down from there, 9. X double prime. Z is 1 below, so I got to go 1 above. And Y is right on it, so Y prime, double prime is going to stay right there. Get a dark green here. This is what it looks like. All right. The translation vector and the reflection line were not parallel to one another. Okay, we need to know a couple more things, and I have this. We're visiting this for a second time. A composition of two reflections in parallel lines is the same as a translation. You're going to need to know that. You're going to be asked it. The distance the figure is translated is exactly twice the distance between the parallel lines. So here's the point. If you did this reflection of the blue triangle over to the red, over to the green. Wow, that's funny. That's what I was doing on my diagrams, was going blue, then red, then green. I didn't do that intentionally. I really forgot. The total distance from here to the end figure, okay, is twice the distance between the lines. Okay, so this total distance is 2 times the measurement that you would get between the lines, which would be h units in this case. We could measure it and then double it. Now, there's another one. A rotation. Now, a composition of two reflections in intersecting lines is the same as a rotation. The angle of rotation is exactly twice the angle between the intersecting lines. So this angle right here, you would double to go from the green one to the blue one. Okay, so right here, this angle, the whole angle is twice the angle between the lines. That's what that's showing. Okay, so all you have to remember is that they're both double the distance between the lines, whether it's an angle or a measurement. Okay? So let's see an example. You see this little dog. You don't have this on your paper. If I measure between the lines, now this isn't even perfect, but say that's 6.5. If I were to measure from tip to tail, the same place, it's twice the distance. And that, I don't know. I can't read it, but it's crooked anyway. I don't like that picture. Okay, this rotation, whatever this angle is right here, say it's 50 degrees, then the whole rotation would be 100. Okay, you just double that number. Okay, that's just another picture of a double reflection. And we used to do this. Actually, I made these in a program called Geometer Sketchpad. We used to have Sketchpad in the labs, and I used to take my students and do this in the lab, which would have been fun, but we don't have that program any longer. So let's do this one by hand. And I'm going to tell you that I want you to try to be neat about it, but it's not probably going to come out perfectly. All right. We're going to first reflect over line A. So some of you will do a really, really neat job. I'm just not expecting them all to look absolutely perfect. I was going to measure on your paper. Can you guys tell me, please? We're going to need to reflect this point P over line A. And I need to get a measurement from, I'm going to line up vertically, or basically I'm using this mark at 5 to vertically line up with line A. I have my ruler horizontal and perpendicular to line A. Okay, so I want to find out how many marks it is to get to P. What are you guys seeing for a distance? So I can maybe try to blow up my ruler a little bit. How many marks on the millimeter side? 7. So mine's way too small. Okay, so let me grow it a little bit. 7. It's still too small. How many are you getting? Only 7? This is 1 centimeter. So you're telling me you're only getting 7 marks past there? Oh. You're saying no? What are you getting, Darylyn? Oh my goodness. Okay, I have a feeling some of you are using inches and some of you are using centimeters. If you're using the inches, is that where you're getting 7, where it's the bigger marks? Okay, from P To line A. It is 7 marks. That's what you're telling me. Got it. Okay. According to your ruler. So my ruler is still too small. I'm trying to get it adjusted so it's going to actually match your rulers. Still a little off. Okay. This is getting pretty close, isn't it? To what you're seeing? All right, so let's agree to let my ruler be at this point, and so we can get on with it. Your guys are saying you're at 5, 6, 7 right here on your mark. All right, you guys go to the other side 7, and I'm going to try to adjust it while you do that. Okay, I think I've got it pretty realistic at this point. There. Okay, so what you would do then is holding your ruler still, you just go to the other side 7 marks, and then label it P prime. Okay, now we're going to slide down. And I don't have to worry about the one that's on the line, but I need to measure to here. Are you guys getting about 1.5? I mean, sorry, 10, 15 marks. 1.5? You're getting 14? Okay. Mine's still a tiny bit off then. But, okay, I'll go with you. You guys go over 14. I'll go over what's going to make my picture look best. Hope you're able to follow me here. And then slide it down. And we got to do the ones down at the bottom. Uh-oh, something happened. You got to stay vertical or horizontally and line up one of these numbers vertically with your line of reflection. All right, I got like 3 away or so on the bottom for one of the points, and then just go out 5, 10, 11, 12 or so on the other part. Okay, get that thing out of the way. You guys can use your straight edge to go ahead and connect those. I'll use my tool. Now, after this, I'm going to see how well I measured by dragging one of these figures over there. Because I'm not perfect, and that's why I'm not expecting you to be perfect, but I'd like you to do as well as you can within some reason. Doesn't want to pick up my... There we go. Oh my goodness, did pretty good. I just took this as a copy of that thing. Oh, it's having more fun than I am. It's not wanting to cooperate. There. Oh, come on. Drag with me. There we go. Boom. Okay. My reflection is pretty accurate. Now, we're going to go the other direction. So what's that going to require you to do with your ruler? Turn it up vertical. Okay, so now we're going to be going this side. So I need to be lined up, and I'm just going to use my 2 on here on the centimeter side, and I'm going vertically with line B. I'm going to slide the ruler, keeping it horizontal, this lined up, my 2 mark, and then I'm going to measure how many marks it is up to P. Are you guys probably getting a little bit more than me or a little less? I don't know. 5, 10, 11, 12, 13, 14, 15, 16, 17. Are you about 17 or 18? Okay. So go to the other side, go all the way to the line. You have to go all the way back to the line and measure from there. That's why I line up with one of my numbers there. And I'm going to go 17 over, or about 17, 18-ish. That's going to be P double prime. Unfortunately, we got a little bit more to move here. Staying at 2, I'm going to get this right corner. And I've got 12. If you have a little differently, Just going to do this. Each point reflect over that line. Oh. My magic ruler can even flop its units. Okay. Once you get finished, we'll want to connect those points. Now, you're going to have a much easier one on your quiz tomorrow. You'll only actually have to measure 1 point to get your reflection done because 2 of them are going to be right on the line. Okay, I probably didn't do perfectly at all. I just was going to give it a shot, though. Take this thing and drag it. Turn it over. Oh, my goodness. Stay. All right. Not too bad. Okay. We good? Yours looks at least something like it. You should be all right. That took way too long. Oh, we didn't answer a question, though. What's the main question? What is the angle of rotation that we have gone and made from going from P to P double prime? How big is it? Where you get 180? Doubling the 90, okay? That's what you do, the angle between the 2 lines of reflection. So the rotation of 180 degrees, because we did 2 times the 90. That's how you were going to describe it. From going from P to P prime is a rotation of 180 degrees. I have another visual way to show you what happened. You can just connect P to P double prime. P double prime. It snapped straight for me. We went right through the origin, 180 degrees. There it is. Yes. It asks, I know, this ended up being clockwise. We were supposed to, though, do it over A, then over B. So this would have been a clockwise rotation of 180. Our normal rotations, when I tell you to do a rotation, it's going to imply counterclockwise, okay? Because all of your rules work counterclockwise, although this one works either way, okay? So if we had rotated this one counterclockwise 180, we'd be in the same spot. So good question, Evan. This is going to be much like what you're going to have to do on your quiz, at least the first step tomorrow. Okay, so we're going to need to measure just this point to go over the line to get this one started. I'm scared to, let me go back. I wish I could just copy this ruler over to that page because I got it started. But I'm going to just give a demonstration. You need to measure, please, from, just make sure you're staying vertical to the line. Okay, you're going to come across the same distance. Now I'm estimating it. I'm going to now take this triangle and show you what it should look like. It'll flip it over. And your picture should look like this. So I was a little bit short. Okay, that'll be your first step. So all you have to do is measure vertically here. This distance needs to be the same as this distance, and it has to go at a right angle to line A. Okay, so please try to reflect that. Okay, to do the next part, everybody got that part done? Anybody need time so I can show what comes next? Okay, we're now going to be reflecting our reflection, which is P prime, oopsie, I need a pen. P prime. We're going to reflect P prime over line B now. Okay. So we're going to have to measure all 3 points because we got to measure from line A to line B. So you're going to put your ruler so that it's lined up with a line matching up on line B, and then you're going to be coming over the same distance across. Okay, and then you're going to have to do the same for P. And that one other corner, this will be the same as the first one, the same length as the first reflection to go to the right side. Oops, bless you. It should look like this when you're done. You don't have to connect them. I'm just showing you what you're supposed to be measuring. Okay. The end result is 2 times the distance between the lines. I measured between those lines earlier on your paper. Can you guys tell me how far it is from here to here? I got 1.7 centimeters. You did inches? 10, you did, so it was 10/16. Let's do on the centimeter side, because so we all agree to something. 1.7 centimeters. So the whole transformation, the single transformation that maps P onto P prime, would be a translation, and it would be 2 times 1.7 centimeters or 3.4 centimeters. That's how you're going to describe it. A translation, 3.4 centimeters. Because see, that's just a whole nother 1.7 right there. Okay? Does anybody still need this page? Okay. This is something you're going to need to know. All right. Now these, you don't have to actually do it. Okay? You just need to tell me what would be the outcome. So if you were to reflect this figure P in line A and then line B, so it'd go over here and then it would come over here. The total transformation would be a rotation of how many degrees? Well, that's 50, so this is 50 because vertical angles are congruent. So it'd be a rotation 100 degrees. You double the angle between the lines. Okay, and then 6, if you have these reflecting and you're going to go over A, you're going to reflect it twice. If you're going to reflect, I'm just going to say, let's just double this angle. So that's going to be a rotation of 90 degrees. I don't know. It might actually be 270, but I'm going to not worry about that right now. Okay, you got practice. Well, let's go to our review worksheet that we got the other day, but I'm going to stop the video and start it